Hello everyone.
Good evening, ma'am.
Yeah, good evening. So this is your week 3 and 4 revision session. So we will solve the questions based on the topic of week 3 and 4. My screen is visible, right?
Yes, ma'am.
Yes, ma'am.
Ma'am, can you share this PDF with us?
Yes, it will be uploaded after the session on the portal.
On the calendar?
On the portal you will find it in the live session notes.
Okay.
Okay, so this is your first question. So we will discuss the question, and along with the questions, whatever topic it belongs, we can discuss the topics. If you have any doubt, you can ask. So the first question is the marks out of 100 scored by Nikita in a semester exam is given as 50, 60, 55, 65, and 70. And if Suman has scored 5 marks more than Nikita in each subject, so based on the given information, answer the following questions. So here we have to find the mean of marks scored by Suman. Okay. So we should know how to calculate the mean, right? So how we calculate the mean? What is the formula for mean?
Sum of the observations by number of observations.
Yeah, sum of the observation divided by the total number of observation, right? And we know that whenever we add a data point to our data set, suppose we have
New
a
mean, new mean equal to old mean plus n times the number of the number added.
yes, so suppose you have a data set, okay, you have data points like this, x1, x2 up to xn, right? So suppose the mean, the average for this data set is x bar. And now what you are doing, you are adding one constant value to each data point. So suppose it is c, so x1 plus c, x2 plus c, similarly for all the xn. So now if you calculate the mean for this data set, what it will be? What will be the average of this data set?
Mean,
Yeah, mean it's obvious, but
Mean
what will be the value for
by
it?
multiplied by
X bar plus C.
X
65.
bar plus c. So it will be x bar plus c. Okay, so it is the same data set. We just have added a constant c to all the data points. Okay, so if the mean for this data set is x bar, so for this data set, it should be x bar plus c. So this concept we have to use in this question. Okay, so now calculate. So first of all, we can calculate the mean or the average for this data set. Okay, so these are the marks scored by Nikita. So what will be the mean calculated?
60, ma'am.
60. Okay, so suppose x is a variable which is representing the mark scored by Nikita.
Your voice is low.
Okay, so x is a variable which is representing the marks scored by Nikita. So we have to find x bar. Okay, so x bar will be summation of I going from 1 to n divided by the number of observation, right? Which is n. So here it will be 50 plus 60 plus 55 plus 65 plus 70 and divided by 5. Okay, so it will come 60. So this is the average marks scored by Nikita, right? In the question, we have to find the mean of the marks scored by Suman. Okay. So suppose y is a variable which represents the marks scored by Suman. So according to the question, what will be the relation between y and x?
X bar
5x,
plus
ma'am.
C.
What?
X bar plus 5.
Y is equals to X bar plus C.
No, no, I am asking that what will be the relation between x and y first?
Y is equal to
X,
x plus 5, ma'am.
Y is equals to X bar plus 5.
y equals to x plus 5. See, y representing the marks scored by Suman. Okay. So Suman has scored 5 marks more than this marks scored by Nikita. So y is equal to x plus 5. Okay. Now we have to find y bar. So y bar will be equal to x bar plus 5. So x bar we have already calculated, which is 60. So y bar will be 60 plus 5. So y bar will be equal to 65. Right?
Yes, ma'am.
Okay. Is this question clear?
Yes.
Okay. So whenever something is given, so the data set is given, and we have done some manipulation with it. We have added some constant or multiplied some constant. Okay, so we have to find the mean or average of the original data set, and then we can do the same kind of calculation with our mean, original mean. Okay, and we can find the mean for the new data set. Okay.
Ma'am, I have a doubt. Can I ask?
Yes.
Ma'am, the professor has told us that for calculating the sample mean for discrete observations, X bar is equals to X1 plus X2 till Xn by, in the one formula it was capital N and in the another formula it was small n. And it was discussed that the capital N is for population mean and small n was for the sample mean. So I want to ask, how does this make a difference?
No, so the thing is, the mean is always the sum of the observation and divide by the total number of observation. So basically, capital N is used for the number of observation in the population, and small n is used for the number of observation in the sample. Okay.
So so it is just used for denoting
Yeah,
sample
it's
and
just for
population mean.
notation. The meaning is like the total number of observation. So if it is sample, so we denote it by small n, and if it is a population, we denote it by capital N, but it does not make much difference. It is just for notation.
But ma'am, in sample, we use in denominator n minus 1, right?
Yeah, that is for variance, but mean, for mean we use n only, not n minus 1.
Okay, okay.
Yeah. So if you are calculating sample variance, then we take n minus 1 in that formula. Okay. That is different. For mean, we have to divide by the total number of observation only. Okay.
Okay, ma'am. Thanks.
Any other doubt in this question?
No, ma'am.
No, ma'am.
Okay. So this is the second
M-
part.
Ma'am,
Hmm.
ma'am, I have a doubt not regarding the question, but in ma'am, is EMQ compulsory or it is graded
See,
in
we have
case?
already discussed this is that week 5 EMQ is not graded. Okay, so don't
Ma'am,
worry about
does
the
they provide
EMQ.
EMQ for week 4? Because I didn't get that till now in my tab.
For week 4, I don't think there is a EMQ.
And there are 3 EMQ, but not graded.
So
For
it
Week
will not
5
be
is
graded.
graded.
It will be,
generally.
see, it will not be graded. It will be for your practice only.
Yes, ma'am.
Yeah, it's for your practice, not graded. And week 5, the EMQ is not going to be graded. Because of some technical issues, it is not going to be graded.
Ma'am, there is written graded part 2.
In week
Did you
6, I
check the mails? We have already had a discussion about this, so let's not waste our time on this thing that week 5 EMQ is graded or not. Okay, week 5 EMQ is not graded.
And
Ma'am,
ma'am,
in
week
week 6
4,
we have.
In week 6, it is graded. Okay, we have already released a mail that week 5 EMQ will not be graded.
and ma'am, week 4 ma'am, there is no EMQ, I think.
In week 4, it's not graded already. It's like for practice only.
Okay, ma'am. Thank you.
Okay, week 6 EMQ will be graded. So don't worry about the EMQ week 5. Okay, it is for your practice only.
Okay, ma'am.
Okay, so let's see the second question. So if the teacher wants to give the marks out of 50 and modify the marks for every student as this, according to this formula. Now, what is the population variance of the modified marks scored by Nikita? So how we will solve this question?
In this, we'll put the marks which are given in the marks and then solve the modified marks kind of by the formula.
Yes. So the data is given to us. This one, right?
நான் உட்கார்ந்து படிச்சு பார்த்த மாதிரி ஃபாஸ்டா பார்க்கணும், பொறுமையா நிதானமா பார்க்க
Can you please
கூடாது.
mute your mic or I'll have to do it? So the data is already given to us. We have to calculate the population variance for it. Right? And then we can do the changes. Okay. So whenever we calculate variance, okay, we have a variance for our data set. Now, if we multiply a constant, okay, so similar to the previous one, suppose we have x1, x2 up to xn, okay, and suppose the variance is sigma square, okay, or I'm just writing variance, otherwise you will ask sample variance or population. So it is, suppose variance of x. The variance for this data set is, I'm representing it with this. Now we have a data set. Okay, what we are doing with the data set, we are multiplying a constant.
New
Suppose it is
variance
C.
equal to C square times old variance.
Yeah, so what will be the new variance?
C
C
square into
square
old
into
variance.
the
Yeah.
old variance.
C square times old variance. Okay, and if we are adding a constant, then if it is
No.
x1,
Variance will be same, no change.
yes, so the variance will be same in that case. So in that case, variance will be the old one only. Okay, so keep these things in mind. So now we have to calculate the population variance. So calculate it. This is the data set. Calculate the population variance for it. I'm writing the values here. What is the formula for the population variance?
Sigma xa minus x bar whole square by n.
It is summation of xi minus x bar whole square divided by n. And here summation will go I going from 1 to n.
Ma'am, here do we need to
N
consider the
minus-
mean as 60 or 65?
Mean will be the mean for this data set. Okay, the question is, we have to find the population variance of modified marks scored by Nikita. Okay, so these marks is for Nikita. So we have to calculate the marks or the mean for this. And for
Okay,
this data set, the mean was 60.
Yeah, 12.5.
Okay, now let's calculate it. So how we calculate it? We can make a table where we have xi value. So the values are 50, 60, 55, 65, and 70. Okay, so look at the formula carefully. We need xi minus x bar and then square of it. So this is xi, then xi minus x bar we will calculate. And then we will find xi minus x bar whole square. Okay, so x bar
Will be
is
50.
60. X bar was 60. Okay, so now this will be 50 minus 60, so minus 10, then 0, minus 5, 5, and 10. And then we have to square it. So it will be 100, 0, 25, 25, and 100. Okay, now we will take the summation of this part, right? According to the formula, what we need? Summation of xi minus x bar square. So this summation will be 250. Now we have to put the values in our formula. So sigma square will be what?
250 upon 5, which is equal to 50.
250 divided by 5, right? So this will be equal to 50. So this is our sigma square population variance for the old data set, right? Now we want, according to the question, we have to calculate the population variance of the modified marks, right? So this is the population variance for the old marks, right? And we have done some modification, so the variance will also be changed. We will have to do the modification in the variance also. So what we are doing, we have multiplied by 50 and divided by 100. Or we can say that we have multiplied by 50 by 100, right? 50 by 100 into mark. So this modification we have done. So now how will the variance will change? What will be the new variance?
C square. C is 50 by 100.
Yeah, C is 50 by 100. So 50 by 100 is square. So we can write that the sigma square of modified marks
1250.
So this will be, I'm writing it here. So it is 50 divided by 100 square times sigma square. Okay. So this will be 1 by 4 into 50. So when you calculate it, it will be 12 by 12.5. Is this clear to everyone?
Yes, ma'am.
Ma'am, once explain this sigma square of modified marks.
Sorry, 60. This 60.
The sigma square of modified marks part. This 50 by 100 whole square into sigma square.
Yeah, this is the okay. I'm writing population variance. So this is the population variance. Population variance of modified marks. Okay. So sigma square that we have calculated, this is for the old marks, right?
Yes, ma'am.
So this is the marks. You can see in the question. These are the marks obtained by Nikita previously. Okay. Then the teacher has done some modification, and the modification is like this. For each marks, what we have to do? We have to multiply by 50 and divide by 100. So it is like in the previous marks, this data set x1, x2 up to xn, what we have done, we have multiplied by 50 by 100 in each data point. Okay, this is, so the value of C here is 50 by 100. So what we have done, we have calculated the variance sigma square for this old population. Okay, now we can do some changes, modification, and we'll get the old new variance for this modified mark. So what we have to do? So it will be 50 by 100 square times the old variance, which is sigma square.
I have doubt in this, like 50 by 100, why we are taking whole square?
Yes, so you can see that
Because
we
if
have This entire is the C.
Yes, ma'am. This is
Right?
50 by 100, right? But why we are
Yes.
taking square for that?
Yeah, so this is how the formula works. If you have studied weak C content, you will see, okay? If you want to verify this thing, what you can do, you just calculate the variance for this, okay? And you calculate the variance for this kind of data. Or if you want to verify in this particular question, what you can do, you have this as previous data, you do 50 by 100 in each data point. You multiply by 50 by 100. And then after doing these changes, then you calculate the variance. Okay,
Yes,
so
ma'am.
you will have some old variance and new variance. And when you look at both the values, it will be 50 by 100 square times the old variance. You can see this relation.
Yes, ma'am.
Okay, so then you can verify it. And we know that this as direct result, so we can directly use it. Okay, is this clear?
Yes, ma'am.
Ma'am, for standard deviation, it would be C or C square.
So for standard deviation, we take a square root. Okay, so ultimately it gets C. So you can see like this. You have variance of x, okay, for old data set, and the standard deviation of x will be square root of variance of x, okay. Now you have done the modification. This is for old, suppose, and for new, you can say the new will be c square times variance of x, right? After the modification, now if you calculate the standard deviation of x, so it will be square root of c square times variance of x. So when you take a square root, it will become c times square root of variance of x. So c times
Excuse me, ma'am.
standard deviation of x. Okay, so for standard deviation,
Hello.
it remains c. Yes.
That means sorry to ask like this means when you are when we are seeing the question, when you are solving and we are just I am just seeing it is looking like I understand, but if we got for each question at least 2 minutes time to solve when we are discussing, we can better remember.
Sorry, what you want?
I means the question you are explaining by looking, it seems that I can understand, but the question is front of me and you are explaining. It is okay, I can understand. But for each question, if we just got a little time to solve, then we can remember better. Actually, means my
Do you want me to solve the new variance?
no
Like,
means before you are
Ma'am,
explaining.
he
Just,
is saying to stop after every question we have to solve first, then you solve.
He wants some time after
okay.
after the
Yeah.
You want, okay, you want to
means
solve first
when the
and then
question
I
is in
solve.
front of us, you are also explaining by looking at it. Just it seems we can understand, but for the exam, I think if I can solve, I can remember better. So.
but you can go for previous year PYQs.
No, that is okay. But means before giving the explanation, just if 1 minute extra to solve.
Yeah,
Yeah, it need
okay.
practice, bro.
Neil, we are short of time actually. She has to complete both
Yeah.
the
Just I
3
wanna
and
say
3 and
that
4.
only.
So this is not a kind of solve with us. This is a summary session.
It's only 2 hour class.
Please don't bother. Let her go with the flow.
Yeah.
So the class, you can solve more questions for your practice, okay? And then you will remember all the things. Okay, now anyone has any doubt?
Ma'am, in question, if they were asked for standard deviation, but not mentioned sample standard or population, what we have to calculate?
No, it will be mentioned. Don't worry.
Okay, ma'am.
Ma'am,
Excuse me.
Yes.
ma'am, when we're calculating covariance, sample covariance, is it n-1 or is it just n?
In sample, we take n-1.
Ma'am, so except for sample mean, it's always taken as n-1.
Yeah, in sample mean we take n only.
Okay, thank you, ma'am.
Ma'am, sorry to disturb in between, but can you please disable the chats because it's disturbing in between again and again.
You can simply mute there.
Could you repeat this constant into sample deviation parts just in a brief? Yeah,
This way.
yeah, just an overview.
Okay, see, I'm saying that you have a data set. Okay, initially you have this variance and you want standard deviation, you will take the square root of variance. That's it. Now you are doing some changes. So you are multiplying by C in all the data points. So your new variance will become C square times old variance. Okay. So
Okay,
this is
just
the result that you have to
just
remember. Yeah.
just multiplying the constant. That's it.
Squared in the
Yeah.
variance.
Okay.
Okay. So if you are multiplying a constant into your data points, the variance will become C square times variance of X, the old variance. Okay. And standard deviation, you will take square root. So standard deviation is C times old standard deviation.
Yeah, ma'am. Okay, ma'am. Thank you.
Yeah, you can remember these points. So it will be easy to solve the questions in the exam. It will save your time. Anything else in this question?
No, ma'am.
Okay, now calculate this thing. Calculate the correlation coefficient between the marks scored by Nikita and Suman. So
Ma'am,
again,
with
I'm
the
writing
new
the
marks or the old marks?
data points. 1 minute. With the old marks only, not modified marks, right? So I'm writing the data points here. So 50, 60, 55, 65, and 70. Okay. So this is the mark for Nikita. And for Suman, it was written that he has scored 5 marks more than Nikita in each subject. Okay, so it will be like the summation. You will add 5 for each data point and you will get the values of, suppose this is X, so it will be Y. And then you can calculate the correlation coefficient. So our X values are, so our X values are 50, 60, 55, 65, and 70. Our Y values will be 55, 65, 60, 70, and 70. Okay. Now, what is the formula for correlation?
Sigma xi minus x bar into yi minus y bar by n.
It's a population, right?
So here we have to calculate, yeah, correlation coefficient. So correlation coefficient will be, yeah, what is the formula?
Covariance.
Bar into yi minus y bar by n.
Yeah, so that is also correct, that covariance of x comma y divided by the standard deviation of x and y.
Yes,
Yes,
ma'am.
that is also
Yes,
fine.
ma'am.
So you
Better
can,
to remember.
and here we are given the data points, so we can find like this: xi minus x bar, yi minus y bar divided by square root of xi minus x bar whole square and summation yi minus y bar whole square. So when you open the formula of covariance comma xy in the numerator and in the denominator, the variance, the standard deviation of x and standard deviation of y, you will get the same thing, right? This n part will be cancelled out in the denominator. So you will ultimately get this. Okay, so what we have to calculate? So this is xi, this is yi. So we have to calculate xi minus x bar. Okay, and yi minus y bar, right? Then we have to take the multiplication of
Ma'am,
these two. Yes.
can you please upload this PDF in the calendar? Like, can you link it in the calendar?
You can find it on the portal itself.
Ma'am?
It will be uploaded there. It will be uploaded on the portal.
Okay, ma'am. Thank you, ma'am.
So these values we need to calculate here, right? It's easy. You first write all these things, what we have to calculate, and then you start your calculation. So X bar was 60, right? We have already calculated it. And what was Y bar? Y bar was 65, right? That also we have calculated. Yes, no?
Yes, ma'am.
Ma'am.
Okay, in the previous parts, we have calculated these two
Yes, madam.
things. So we
Yes,
have
ma'am.
to now calculate xi minus x bar, right? Which means 50 minus 60. So it will be minus 10, 0, minus 5, 5, 10. So here it will be yi, these values minus 65. So it will be minus 10, 0, minus 5, 5 and 10, right? Now we have to take the multiplication of these two, right? So minus 10 into minus 10, 100.
Ma'am, I think
Zero.
it will be 250 because you have done it earlier.
Yes, we have done it. So this is this, okay? Then xi minus x bar whole square. So this is also the same values. Okay, and we need the summation of these parts. So this will be 250, right? This is
Yes,
250.
ma'am.
This is also 250. And this is also 250. So this summation is 250, then divided by square root of 250, square root of 250. So this will become 1. Right?
Yes, ma'am.
Yes, ma'am. Ma'am, isn't it divided by n, like the total number of observation? Xi minus x bar into yi minus y bar divided by n.
That is covariance.
Yeah, that is covariance. So when you look at the formula of correlation, it is covariance of x comma y divided by the square root of variance of x and variance of y, right? So when
So,
you
ma'am,
open the
so wouldn't it
formulas,
be 250 divided by 5?
yeah, let me explain. I'm explaining the same thing. So when you open the formulas, you will see the denominator part of the covariance and this square root of variance and square root of variance of x and square root of variance of y will be cancelled out.
Okay.
Okay. So this is summation of xi minus x bar, yi minus y bar divided by n. Suppose it is population covariance. Okay. So here also it will be like this, summation xi minus x bar whole square divided by n. And here it will be summation yi minus y bar whole square divided by n, right? Now you can see these n and these will be cancelled out. Okay, so we don't need to write these values.
Okay. Okay, ma'am.
Can we say that the nature of the correlation coefficient is strong or positive?
Sorry, what?
Can we conclude that the correlation coefficient is strong and positive
Yes, we can say
in nature?
getting the value 1 and it is positive. So positive, strong positive correlation is there between x and y.
Okay.
And what is the significance of capital R square? What to analyze it by?
Capital?
Yeah, capital R square, na goodness of it line.
Yes.
So, what is the purpose of it? Why do we use and how to calculate this? There was an example in the lecture, but don't know how to calculate or what to know
So that
about it.
actually like gives you the relation for y equals to mx plus c line. For that we use it. So this concept is not in detail, so I'm not taking those questions. So basically it is used for this linear relationship y equals to mx plus c line. So it checks the goodness of it of this line to the data set.
They say that it lies in the range 0 to 1. So basically, if it is 1,
It
then
actually gets squared. The correlation terms gets squared, so it becomes 0 to 1. So for correlation coefficient, the range is from -1 to 1, right? When you
Yeah.
take the square of these values, so it will be ranging from 0 to 1.
Okay.
So that's why capital R belongs to in this range, 0 to 1.
Okay.
Excuse me, ma'am.
Hmm.
Hello.
Yes, yes.
Ma'am, the correlation coefficient is from -1 to 1, and the RPV point by itself coefficient is also from -1 to 1, or other range.
Point by serial is 0 to 1 we take.
Point by
So
series.
there we take absolute values.
No, means RPB I'm talking.
But there we take negative values as well.
Yes, ma'am.
You're asking about point by serial correlation, right?
Yes, I'm asking that the correlation coefficient is also -1 to 1, and the point by serial that is between two numerical, that is also -1 to 1.
Point by serial is not two numerical. Point by serial is between one numerical and one categorical
Oh
variable.
yes, sorry. Yes, ma'am. Point by serial, one categorical and one numerical. So there also we have -1 to 1.
No, that is 0 to 1 because when you calculate that, if you look at the formula, we take the absolute value. We take the difference of y0 bar and y1 bar. So we take absolute value, so you will get the values between 0 and 1. If you're not taking the absolute value, you will get the negative values.
Oh.
Okay, but we should take the absolute values there.
That means for the correlation coefficient, we have the definite ranges for which the relation will be strong, weak, moderate. So for RPV, we do have something like that. Means
No.
means for correlation coefficient, suppose means -0.25 to 0.25, there is no linear relation. Then after that, the moderate, then strong, like that we have. Yeah. So, but
So
in
you can say if it is near to 0, the relation will be weak, and if is the value is near to 1, the relation will be strong.
This serves the same purpose as of the correlation coefficient.
Yes.
Okay.
Ma'am,
Okay.
sorry, ma'am. Means could you please for the correlation coefficient list the ranges for which the relation will be weak, strong, the categories. Means I am making mistakes in that type question. That just the categories means within which range to which range the relation will be weak, then strong, then moderate. That list could you please just give once. I'm making mistakes in that.
For correlation, right?
Yes.
Okay. So the correlation value lies between 0 and -1 to 1.
Yes.
Suppose this is 0. Okay.
Okay.
So this is for negative side. This we will take from the positive side. Okay, so you might find the values near to these values. So how we can say that if you are getting the values between this range, then we say that there is no association, right? The value is very near to 0, so we can say that there is no association or very weak association if it is like -0.25, very weak. Okay, which means the variables are not affecting each other very much.
There
And
is
if
no linear relation.
yeah, there will be no linear relationship between them. Okay,
Yes.
if the value is near to in this range 0.75 to 1, so then there is a strong positive linear relationship. Okay,
Okay.
a strong positive.
Okay.
And if it is in this range, then will be strong negative.
Negative.
Okay, and if it is between these range, then we can say that the reasonable relationship is there, reasonable association. Okay, if it is near to these value, then it will be strong. Otherwise, there also they are related, but we can say reasonable, but not very strong.
And the weak and moderate I'm asking is weak will be between 0.25 and 0.5. Am I right?
Between this range, it is very weak or no association. Actually, it is
No, I'm asking.
near
This
to
is no
zero.
association. I'm asking weak. Means
Sorry,
this was no association, but I'm asking the weak association. That will be within which range?
this is weak only if the value is near to 0.25 or this is very weak.
Okay. Okay.
If the
Ma'am,
value is near to zero or exactly zero, which means no association, near to zero is weak association. We cannot be strict with this value that if it is 0.5, then this is not like that. We can just say in the range, but not a very strict point. If it is exactly
0.25 to
zero, then
0.75 could be moderate.
no, not moderate. It will not be moderate. It will be weak associations from 0.25 to 0.25. Okay, this range. If it is near
No,
to
no,
0.5,
0.25 to 0.75.
see, it's not classified like that. It's just for understanding. We cannot be very strict with the values that if it is in this range, then we will say like this.
Ma'am, between minus
Zero.
0.25 and
If,
0.25, there
ma'am,
is
if
no
the
association.
value is
Means not even
closer
weak.
to zero, is it like weak?
Yeah, if it is zero, if it's near to zero, if it's exactly zero means no association.
No, I
Near
say, but
to
if it's
zero,
like 0.2 or like 0.3,
yeah, it's
0.4,
very weak
0.5, that's
association.
weak. Okay.
Yes.
Ma'am, in 0.1, 0.2, that there is also no association. Means we were, I think, told that between minus 0.25 and 0.25 there is actually no association, not even weak.
Yes, ma'am.
It's near to zero, which means no association.
I mean, the
Absence of
lecture, they
association.
basically specified the values like from minus 2.5 to 2.5, as you told, there is no association. And from 0.25 to 0.5, there is weak association.
Yes, it will be weak in this range. If it is greater than 0.5, you will be saying that there is a reasonable relationship.
Understood, ma'am.
I should not make this line actually. Okay. And if it is greater than 0.75, it is strong. Okay. Depends on the sign. It will be strong negative and strong positive.
Ma'am, one question.
Clear?
In this sum, so this y variable is actually obtained by adding a constant, right? So
Yes.
the variance is going to remain same, standard deviation is going to remain same. So can we directly say coefficient is 1 without calculating the values?
You can use this relation that y equals to mx plus c. Okay. If between the x and y variable, this kind of relationship is there, you can say that the correlation coefficient will be 1 or minus 1 also, depends on the value of m, sign of m. Okay. So here you can see that y is equals to x plus 5.
Yeah.
Right. So it is following this format. Okay. So there is a strong positive correlation. So they are, the correlation between them is being 1.
Okay, thanks.
Okay. If there is a negative sign coming here, then it will be going towards minus one side. So it will be like the opposite direction, but the strong relationship.
Ma'am, hello.
Yes.
Ma'am, in graded week 4, I had one question for which I got SX is 1.38. It was in the range. And SY I got 2.80. It was also in the range. So got it correct. And covariance of X and Y was also in the range. But when it came to correlation, it suddenly was wrong for the same value.
It's going out of range.
Means for me Sx 1.38, Sy 2.80, covariance Xy minus 2.98 for the given data question. So these three values were correct. So my correlations should also be correct. Calculation is correct. I got minus 0.77 value, but for the answer they are saying it was minus 0 point something. It was wrong, my correlation coefficient.
See, if you are doing some decimal calculation, so if you're like, if you round up to one decimal place, two decimal place, the value gets changed.
Yeah, means value will change, but for the given range, mine is correct. For Sx is correct, Sy is correct, and covariance
That
of
should
x
also
and
be correct, actually.
no,
You
they
have
are
checked it
it is
together.
wrong. No, the answer is incorrect. Range they are given ranges 0.73 to 0.67 minus both are, but mine got for the for these three my answer is correct. So for that calculation is minus 0.77.
Okay, I'll see. I have to check the question.
Thank you.
Okay, solve this question.
Excuse me, ma'am.
Yes.
Ma'am, the range you are given for the correlation coefficient, there is no such like the no relation weak and strong does similar values exist for the RPB? Means it is lies from 0 to 1, but within which range it will be strong, within which
No,
range
it's
it will
not
be weak.
particularly defined. We just can say that if it is near to 0, then there is a weak relationship. If it is near to 1, there is a strong relationship. It is between, then near to 0, which means weak relationship, right? And near to 1, strong relationship. Between, we can say that reasonable, not very strong, not very weak, something like that.
Okay.
We don't have specific values for it.
Ma'am,
Yes.
so actually I solved a question, weekly question, graded assignment. So there my R value came to be 0.22. So I chose the options weak and positive. So, but the actual answer was there is no linear relationship. So how can I check that?
It's 0.2.
0.2, yes, ma'am. 0.22.
Okay, I'll see the question. So you can check the graded assignment solutions. The explanation will be there. Okay, you can check that.
Okay, ma'am. Okay, ma'am.
We have solved only one question. Only 1 hour is left, so we should solve it. Graded assignment solutions, you can check. It's uploaded, and you can check the explanation, how they have explained, then you will understand it. Okay, solve this question. We have to calculate the 25th percentile for this data set. So this
Ma'am,
is the stem and
2.5,
leaf
so
plot.
answer 18.
Okay, so stem and leaf plot. So this is representing the ages and years of a group of people attending the paradox event.
Ma'am, I got the answer as 2.5. So why 18? Why can't I say that 15?
Yeah, you know the how to calculate the percentile?
Ma'am.
How to calculate it? Then?
100.
No, ma'am, please
If
explain it.
NP is not integer, we will get the
No,
increment it.
let him explain.
K by the percentile amount by divided by 100 into n plus 1.
You have to use the formula n into p, right?
Yes, ma'am.
So n is 10 and p is 0.25. Okay,
Ma'am, n is 9.
n is 10.
N is 10.
Okay, first tell me how to interpret this stem and leaf plot. What are the observation in the data set?
Ma'am, 31 is repeated twice.
So 31 is repeated twice, but we have to take it 2 times, right? We cannot skip one value. So this is 40, 50, 18. Okay, then 21, 22, 24, right? Then 31, 31, 32, 33. Okay, so you can see the data set is representing the ages of a group of people. So 2 people might have the same age, okay, but you cannot say that there are only 9 people. There are 10 people. They can have the same age. This is possible, but you cannot say that there are only 9 people. You cannot skip one person. The number of observation you have to count all the values. It is repeating. They have it. The value 31 have frequency 2. That's okay, but the total number of observation is 10, not 9.
Yeah, ma'am.
Ma'am, for percentile, we will be always using the formula NP because there was one more formula in the lecture, rank and percentile, which was basically used in the Google Sheets.
See, Google Sheets works differently, but for here we have to use this formula only, NP, okay? So we
Here
have
and
to
also
calculate.
the
For
questions we will get, we have to use this formula only. NP.
yes, you have to use this formula only. Okay, so we have to calculate the value of NP. So here n is equals to 10, and why the value of p is 0.25? Because we have to calculate the 25th percentile. So it is nothing but the 25th divided by 100. You will get 0.25. Now the value of NP will be 10 into 0.25. So this is 2.5. Okay. So whenever you calculate the value of NP, there are two cases. The value of NP is an integer, or it is not an integer value. So if value of NP is integer, we have to take, suppose if it is coming out to A, so A and then A plus 1, we have to take the average of these two values. And if it is not an integer, then we have to take the value which is the nearest greatest integer to that particular value we are getting in the decimal. So 2.5, the nearest integer which is greater than this value will be 3. Right? So here the third observation will be our 25th percentile. Okay. So we have to take third observation. So 25th percentile is equal to the third observation, which is 18. Okay. And whenever you are calculating the percentile, you always have to sort your data set. Okay. In the ascending order, you have to arrange. So here we have already arranged it. It is already arranged.
Can you explain the integer, not fractional case?
So suppose if the value of NP is coming out to be 3. So what you have to do, you have to take third observation and fourth observation, and you have to take the average of these two. And if you are getting non-integer value, suppose 2.5, so the next integer which is greater than this value is 3. So you just directly have to take the third observation. Okay. In this way, you have to calculate it. So our 25th percentile value is 18.
Excuse me, ma'am.
Hmm.
Ma'am, in the graded assignment, no such problem, but in some in the activity questions, when I was using this formula to calculate percentile, the answer I was getting it was wrong, and since there was no solution, it was activity question. I checked the net if I was doing it wrong. There were this formula was not coming, and some other formula I was using. Then I was getting the answer matched.
No, it's not like that. For activity question, for our portal, you always use this formula only, and you will get the correct answer. You might
I
be doing
use this
some.
formula. Ma'am, can I just show one questions, but or tell one question? That is,
No, not now.
ma'am, that is, it is AQ 3.5 question number 5.
You can check the activity video solutions.
Could be
Okay.
still where I
If it
can
is,
find.
you can check. You can find it on the portal itself.
Okay.
Okay. So there are all the video solutions also for all the activity practice assignment questions. So if whenever you are getting stuck in the question, you can check the videos first. So for activity question, we have used this formula only. You will get the correct answer.
Why we are taking n is equals to 10?
Okay, now calculate the 75th percentile. Again, the value of n is 10 and the value of p will be 0.75. Right?
Yes, ma'am.
Now the value of NP will be 10 into 0.75, which means 7.5. So which observation? will be the 75th percentile.
Eight.
31.
Yeah, 8th observation. Okay, so 75th percentile. So 8th observation you can check from here. This one, okay, this observation. So this is 31. So 31 is the answer.
Sorry, in terms of 99%, that is a thing. Could you clarify the part? I get ambiguous with the part.
Sorry.
If there is 99%, I think I still remember there is a kind of ambiguous situation. How do you consider that the 99%? If
Yeah,
it's not
so you will
75,
use yeah,
yeah,
so in
so
99, so the value of P will be 99 divided by 100. So P will be 0.99.
okay.
Same thing we
Understood.
have to use
The
here.
last observation.
Is it the
But
last
here the
observation?
99% and 100% are becoming equal.
Because the data set is very
Ma'am, if
small.
they're 80, ma'am, if
So I
they're
have,
asking for the
It depends
80th
on the
percentile,
see
excuse me, ma'am,
these
can you
things
hear me?
actually we use for the large data set, but here you have very small data set, so you will feel these kind of things here.
no, now that if it's P is 0.99, that's so I have to go for 1. So that will be the first element here.
It's 10th element, no?
Oh, sorry.
It will be 10th last observation.
Yeah, sorry.
Ma'am, could we
Excuse me,
use
ma'am.
here? Hello?
Yes. Yes.
Excuse me, ma'am. Hello. Ma'am,
yes.
could we use here if we have to find rather than 25, 75, this formula number of values below the specific given percentile divided by n into 100?
See,
Hello.
there are some other formulas also for calculating the percentile. Okay, but for this particular course, we are using these formulas. So
Actually, the problem that is happening that in the activity question, when I'm using this formula, I'm getting the answer wrong. But the other formula that told when I'm using that, then the answer is matching with the activity question.
no, I don't consider your problem because we have solved all the question in activity. You have to use this formula only, which what we have explained in the lectures, and you will get the answer.
Excuse me, ma'am.
Yes.
Excuse me, can you hear me?
Yes, yes.
Yeah, in the lectures, they had been saying about two steps. Like if NP is not an integer, then the smallest integer greater than that will be that element. And also, if it is an integer, then NP and NP plus 1 is added and divided by 2, like taking the mean. I do not get that concept well.
You do not understand this thing?
Yeah, I do not understand this thing. Like, what if it is 80 percentile? If like we get an integer when we do NP.
Yeah, just 2 minutes back, I have explained this thing. So if you are getting an integer, two cases are there. If the value will be integer or it will be a non-integer, okay? So suppose the value of NP is coming a decimal value. Suppose it is 2.5 as in this question, or it might be suppose 4. This is an integer, this is not integer, right? So if it is a not
Yes, ma'am.
integer, then what do you have to do? The next integer,
Okay.
right? So it will be the third observation. If you are
Yes,
getting
ma'am.
4, then what do you have to do? It will be the fourth observation and fifth observation and the average of these two.
Okay, so it will be like take that observation, like the
And the
fourth
next,
observation and fifth observation, and then mean.
yeah, then calculate the mean.
Okay.
Ma'am.
Excuse me, ma'am.
Ma'am, this is for
coming
numerical letters,
2.0.
isn't it?
Just want to ask that.
Sorry?
Suppose it is coming 2.01, suppose. Then also it will go to third.
Yes, if it is in decimal, not a complete integer, then we will take this case only.
Excuse me, ma'am.
Ma'am, can we go to the next question?
Just a second, ma'am. I just want to ask that in the quiz one, would be the in percentile question just like rather than 25th percentile, 75th and 5th, just like 61, 62 and
Yes, it can be there.
and
You
then we
have
have
to
to
use the
use
same formula only. By
this
using the
formula.
same formula, yeah, this formula only, NP.
But
The value of P only will be changing. Okay. So you should know how to calculate the value of P. So
yeah, ma'am.
P,
Excuse me, ma'am.
so if it is,
Yeah, I know,
let me,
ma'am.
okay, then what's the issue?
I was just asking us.
I do not have the activity video.
Wait,
Please just take
wait
one
now.
question. The problem will be evident. The problem is happening with the question. Just one question of activity 3.5.
Let me
Then take it
complete,
at
bro.
last.
Oh, okay, okay.
Yes.
Yeah, can I go, ma'am? Ma'am,
Yes, please.
as mentioned above by someone, I don't remember it, that 99 percentile and 100 percentile and same. So if we are using this formula, it will, of course, come the same 99 and 100. So in case what to do?
See, you have to stick with this formula only.
Okay.
See, the thing is, you have only 10 observation, right? If you
Yeah.
divide the very less number of observation into 100 parts, right? So you will not get any data point in between. So these things actually work for large data sets, but you can calculate it. So these kind of things might be there. You have only 10 data points and you are dividing into 100 parts, right? Percentile, which means that each percentile contains 1 by 100 part, right? Percentile, there are 19.99 points. This is your data
Yeah.
set, suppose. So it divides your data sets in the 100 equal parts. So you have only 10 number of data points and you are dividing into 100 parts, right? So maybe in one interval, you will not get any data point, something like that. So that's why if you look at the smaller data points, smaller data set, then you might face these issues.
And here n is 10 only. So
Yes, there are
that's
only 10 data points. So
okay, ma'am.
because of the
Thank you.
small number of observation, it's happening.
Okay, ma'am. Thank you.
Yeah, now calculate the IQR. What
It's
is the formula
31
for?
minus 18, that is 13, ma'am.
Yes, so the formula is Q3 minus Q1. Q3 is what? 75th percentile. And Q1 is 25th percentile. And that we have already calculated. This is 25th percentile. So this was 31. This was 18, so it will be 13. Okay.
Yeah.
Ma'am, can you please revise the formula for outlier?
I'm writing the formula, but outlier questions will not be there. So this is Q1 minus
Outlier.
1.5 IQR. Okay. For lower limit. And Q3 plus 1.5 IQR. IQR is same as interquartile range. Q1 is the first quartile and Q3 is the upper quartile, third quartile. So this is your lower limit and this is your upper limit.
Ma'am, I had
So
not
if any
seen
data
any.
points,
Excuse me.
yes.
Ma'am, I had not seen any question regarding this point y in PYQs.
Ma'am, generally for outliers, we basically see the extreme points. So when to use this formula of checking?
Yeah, extreme points are outlier, but it depends on how strict you are with the outliers to whom you are considering. We use these formulas.
So we need to check always that the outliers we have got as our answers are in this range or not.
Yes, you should check with the formula.
Okay.
So if the value coming below this point or upper to this point, then it will be an outlier.
Okay.
Sorry, just for my clarity, that will be Q3 plus 1.5 times IQR. Is it?
Yes, Q3 plus 1.55 QR.
Okay.
Okay, now solve this one. So here, this table shows the count of sales of shirt at men's clothing retailer. So you have to choose the correct options. So as we already know that option number A and D are correct. So how to verify it? Option number A is that of all the shirts with polo style, there are 26.67% shirts of medium size. So how will you calculate this thing? How will you calculate this proportion?
By the polo shirts of medium size divided by all the polo shirts.
Yes.
That is 20 by 75.
So
Multiply
of
by 100.
all the shirts with polo style. So how many shirts are there with polo style in total?
75.
75.
This one, right?
Yeah.
Okay. So the total is 75. And there are shirts of medium size. So medium and polo. So this is this one, right?
20.
So 20 divided by 75. So this will be 26.67%. Right? If you take the percentage. Is it clear?
Yeah, ma'am.
Yes.
Okay. So the A part we can check. This is 20 divided by 20 plus 20 plus 35. This is giving you the total shirts of polo style. So 20 divided by 75. Okay. If you do 100, you will get the percentage. Now the B part is of all the shirts with small size, there are 25% shirts of small print size. So now we have to take all the small size shirts.
25
And
plus
then
35 plus 40.
90 by 95.
So it will be 25 plus
By
35 plus 40. So this is the total small size shirts. So the total small size shirts is 25 plus 35 plus 40. We have to check the small print size type. The
40.
small print is 40. So this is 40 and this will be 100. So this should be 40%. Right?
Some denominator should be 95.
Why 95?
55 plus 40.
No,
It
it's
is 25 plus 35 plus 40, right? 25
20.
plus 35 plus 40. So it will be 100.
60 plus 40.
Okay. So B is wrong. Option number A is correct. Now we have to check for the association thing. So for association, we can calculate the row relative frequency or column relative frequency, right? So this total will be 100. This also 100. This is also 100. Right? And here 135, 75, and this will be 90. So now we can calculate. So we can calculate row relative. Okay, that is easy to calculate. We just have to divide by 100. Okay, so it will be 0.25. Then it was 0.35. It was 0.40, right? And then 50, 20, 30. So it will be 0.50, 0.20, and 0.30. Okay, are you understanding how am I calculating this part? Okay, we have to
Yes,
divide
ma'am.
this one with the row total. So next one will be 0.60, 0.20 and 0.20 again. And the total also we need to divide. So we have 135 divided by 300, then 75 divided by 300, and then 90 divided by 300. So it will be 0.45, 0.25, and 0.30. Okay, now you can see the values are different from each other,
Yeah.
right? The values are not close to each other. You can clearly see.
Association.
So we can say that there is an association.
Yes, ma'am.
Right?
Here 0.20 is equal to 0.20.
You have to see all the values. So you can see 0.25, 0.50, 0.60. They are not close to each other, right? Here also you can see 0.35. These two only are close, but look at the other values. We have to consider
see the
all.
whole data.
Okay. If all are close to each other, then only we can say that.
Then we have
that
to
there
check
is no
both row
association.
and column. Or anyone we can also check.
We have to check for all the rows, all the columns like this. So we have calculated the row relative frequencies, right? So we have to check these values are similar to each other or not. So you can see it is 0.25, this is 0.50, this is 0.60, and this is 0.45, which are not close to each other.
Ma'am, we have to check row wise or column wise.
Excuse me.
See, we have calculated the row relative frequencies, right? So we have to check like within all the columns, they are similar to each other or not. This is one row, this is the second row, this is the third row. So in the first column, they are similar to each other or not.
Excuse me, ma'am.
Hmm.
And when we are checking row relative frequency, we have to check each cell of the column or each cell of the row.
Like this, you have calculated the row relative, right?
Yes.
You have divided by 100. So you have to check these, and these are similar or not.
Okay.
But it should be a specific in the question itself. It must be there, no ma'am, some clue that whether we are going to calculate row or column.
No, you can use any of the method. Both the methods will give you the same answer. I am talking about the answers, not the values. Okay. Values will be different because you will be dividing by the column. So these values will be different, but the only thing is that if they are close to each other, then there will not be an association. If they are varying from each other, then there will be an association. So you can use any of the method. You can divide by row also, or you can divide by column also. That's your choice. Okay.
How much difference we can have, ma'am? Because the 0.35 and 0.40 is nearly same, right? So how can we say it is same? Like
Okay,
one or two difference is
so the
allowed,
thing
or
is, you can
how many points we can consider?
okay, you can see this thing by making a stack bar chart of it. If you are getting confused how to check, you can see. So here we have three sizes: small, medium, and large, right? And in these categories, we have three different styles, right? So we can make a stack bar chart. So we have three major categories: small, medium, large, and we have then button down, polo, and small print. And you can see that for small, we have 100, for medium also, and for large also, we have 100 shirts for each. So suppose this is small size, this is for medium, this is for large. Suppose this is 100, okay? So if I try to make the graph of it, stack bar chart, so this will be equal because all are having 100 number of shirts. Now we can further classify it. So small size has 25% button down, 35 polo and 40% small. Okay. So from the entire, suppose so this is suppose 25%, this is 0.35, and this is 0.40, 40%, right? This is button down, this is polo, and this is small size, small print. Similarly, for medium, you can see we have 50, 20, and 30. So if you divide, so this is 50, then 20. So this is 0.50, this is 20, this is 30, right? Button down, polo, and small print. Then for large, we have 60, 20, and 20. Okay, this is a proportion also. If you divide, okay, we have to take the proportion or the percentage. So 60, this is 60%, this is 20%, this is also 20%, right? Now you can see, now you are feeling the difference, or you are saying the same proportion in all the small, medium, and large. Now you can feel this thing.
Yes, ma'am, I can
So
see the
here,
difference.
yeah. So here you are saying that you can see that it is 60%, here 50, and here it is only 25%. So there is a huge difference between them. They are not close to each other.
Okay, ma'am.
Right? Now you can understand it?
Yes, ma'am. Yes, thank you.
Yes, ma'am.
Okay, so we will say that there is an association.
Here, since the graphs are not similar, so we are saying that there is association.
Yes. If the values will be close to each other, the graph will also look like similar to each other, right? If the proportion is similar.
But here the graphs are not similar.
Yes.
Sorry?
Values are not close to each other, right?
Okay.
Okay, so we will say that there is an association. Okay. Okay, the next question is, table Q.3 represents the heights in inches of 5 fathers and their sons. So we have to calculate what is the value of population covariance between X and Y. So first of all, we should know the formula of covariance, right? So the covariance between X and Y so this is xi minus x bar, yi minus y bar divided by n, right? So we
Yes,
have to
ma'am.
calculate population, so we will divide by n. Okay, so now again we need to make a table. We will write xi values, yi values, then we have to calculate xi minus x bar, then yi minus y bar, then we have to multiply both, right? These things we have to calculate.
Yes,
So
ma'am.
xi is 65, 65, 60, 80, and 80. Okay. Yi is 60, 60, 55, and 75. Okay, calculate it first. Then I will solve it.
Ma'am, may I know the answer?
What's your answer, Kami?
80.
Answer should be 70.
I'll try again.
Yes, for x it is 70.
Okay, so what is the value of x bar? It
70.
will be 70. Y bar?
65.
65. Okay. Now just subtract x bar from xi values. So this will be -5, -5, -10, 10, and 10. Here it will be -5, -5, -10, 10, and 10. Now we just have to multiply. So this should be 25, 25, 100, 100, and 100. And we need this
350.
summation.
Ma'am, the answer is 70.
Yes. Okay, so this summation will be 350.
Ma'am,
Now
answer is 70.
now we just have to put the values in this formula. Okay. So the covariance of x comma y. So the summation is 350 divided by the number of observation, which is 5
5.
here. Okay. So it will be 70. Okay, now everyone knows how to calculate the covariance. What things we need to calculate.
Yes, ma'am.
Okay, you should always make this table and then the calculation will be easy. Okay, you will not get confused in this way.
Can you show the question once? Is it asked or calculate covariance or sample population like they
Yeah,
have given?
it is mentioned here that we have to calculate population covariance.
Okay, ma'am. Okay. Yeah.
Okay, anyone has any doubt in this?
No, ma'am.
Okay.
Could you please
No,
share
madam.
this PDF?
It
How
will be
many times
uploaded
you
on the
will ask?
portal. Be attentive in the class. I have already told this thing so many times. Yes, this question. So if we have a data set, okay, then you have to choose the correct option. So we have to calculate the range, median, 25th percentile, and IQR. So what will you do first?
Highest marks minus the lowest
Ascending
marks.
order.
Order it.
Ascending order, ma'am. Arranging in
Ascending
Yes.
order.
So first of all, we should arrange the data set and then start solving the other parts. Okay, because for range also, for median also, for percentile also, you have to arrange the data set. Okay, so the first step should be arranging the data set in the ascending order. So the minimum value is here 23,
23.
then 28, then 42, then 45, then 95, and then 194. So what is the range?
171.
Yeah, what's the formula?
Highest minus the max minus minimum.
Yes, maximum minus minimum value. So here maximum is 194 and the minimum value is 23. So it will be 171. So you can see the value is different. So option A is wrong. Next, we have to calculate the median. Okay. So for median, we should know the number of observations. So there are 6 observations here.
It's
So n is 6. So
Average of
6
third
which
term and fourth term.
Now, my average is median is 43.5.
43.5, ma'am.
A median and average are not same.
Median is average of third term and fourth term.
Yeah, that is okay. No, that's fine. So n is 6, which is an even number. So what's the formula if you have even number of observations in your data set?
N by 2 plus 2.
An
N by
average
2
of
plus
6
n,
and
plus,
7.
n by 2 plus 1
6 and
average.
7 term.
So this is n by 2th observation plus
Plus n by
n by
n
2th
by
plus
plus
1
1 of
observation divided by 2. So these two are actually the middle two observation. So here it will be 6 by 2, which means third observation, right? And 6 by 2 plus 1, which means fourth observation, divided by 2. So the third observation here is 42 and the
42.
fourth is 45.
87.
So 42 plus 45 divided by 2. So it will be 43.5, right? Okay. So median is 43.5. This is correct. Now we have to find the 25th percentile. So 25th percentile.
25th percentile will be 28.
So N is 6, P is 0.25. So NP will be 6 into 0.25. So it will be 1.5. Okay. Which means second observation. Second observation, right? Second observation was 28. Okay. So 25th percentile is 28. Okay. Now in the next option, yeah, so this is also correct. In the next, we have to calculate the IQR. So IQR, which means we have to calculate the 75th percentile also. So 75th percentile. So N is 6, P will be 0.75. So value of NP will be 4.5.
Yes, ma'am. Fifth observation.
Okay.
95,
So,
ma'am.
yeah, so fifth observation. Okay, so 75th percentile value is 95. Now we have to calculate IQR. Okay, so Q3 minus Q1. So Q3 is 95 and Q1 was 28. Okay, so it will be
67.
67. So we can check. It is 72, which means option D also is wrong. It's not right. Any confusion in this question?
Excuse me.
No, ma'am.
How Q1 is 28?
Yeah, Q1 is the 25th percentile.
Yes.
Okay, so we have to calculate it in this method.
Okay.
Okay. So Q3 is actually 75th percentile and Q1 is our 25th percentile. Okay. That we have calculated. Now solve this question. The average of 15 observations is 48. The average of first 8 observations is 42. And the average of last 8 observations is 54. So what is the value of the 8th observation? Please mute your mic if you don't have to ask anything.
Yes, ma'am. It would be the average of 42 and 54, right? 42 plus 54 by 2.
Ma'am, 42 plus 54 and then divide by 2. It's 48.
Someone's mic is on. Can you please mute it?
It would be 42 plus 54 by 2, like 48.
Okay, let's solve. So whatever is given to us, first we will note these things. So the average of 15 observation is 48. So average of 15 observation, what will be the formula for it? If I have to write this step in mathematical way, what should I write?
Summation xi I is equal to 1 to 15 divided by 15.
Yes, so summation of xi is where I is going from 1 to 15 divided by 15. So this should be equal to 48. Right? This is given to us. Next is that average of first state observation is 42. So first state, which means that I should be going from 1 to 8, xi divided by 8, first state observation. So this is 42. And then we are given the average of last state observation. So for the last state, what should be the value of I here?
I is 9 to 50. I is equal to 9 to 50. Hey, sorry. 9
8
to
to 15.
6.
Yes, ma'am. One element is common.
So it will be 8 to 15, right? So 8 to 15, there will be 8 observations. Okay. So 8 to 15 are your last 8 observations. So these information is given to us. Now we have to calculate the value of 8th observation. Okay. So 8th observation, how can we find? So we know that summation of I going from 1 to 15. Okay. So this should be equal to I going from 1 to 8 xi plus. So this value we can calculate from here, right? These value we can easily find. The summation of I going from 1 to 15 xi. This will be 48 into 15, right? From here we can calculate I going from 1 to 8 xi. So this will be 42 into 8, right? And from here we can calculate summation I going from 8 to 15. So this will be 54 into 8. Okay, now if I write this
Excuse me, ma'am.
equation.
Hello.
So this will be 8 to 15. Now is this equation balanced?
No, ma'am. No,
So what
ma'am.
should I do?
Minus the 8th observation.
Minus 8th observation, right? And then this equation will be balanced. And now we know the values of these summations, right? We can easily put these values. So I 1 to 15 is 48 into 15. So 48 into 15, what will be this value?
720.
I'm here 15 observations were given, so it was small, we could easily identify, but suppose a large number was given and then it was told last 8 observations, so how could we means write that from which term to which term?
You have to calculate it. We'll have to
Means
see
here
what
we
will
could
be the
understand that the mean of last eight observation is the summation of 8th observation to 15th observation, but suppose a large number was given, so
then also you can calculate in the same way.
Maybe the number of observation would be given there.
It will be given.
Yeah. There's a note shortcut, bro.
You have to use some mind and you can find it. If you have 100 observation, if you have n is equal to 100, and if I ask what will be the last 2 observation, like this in the serial, last 2 or last 4, from where will you start? It will be 97,
Ma'am,
98,
excuse me.
99 and 100. Okay, these are the last 4. Similarly, if you have n equals to 1000, then also you can find.
okay, sorry, I'm actually I was making mistake, sorry.
The required data would be given there.
Yes, okay. So I going from 1 to 15, this was 48 into 15. So it will be 720. 1 to 8, this summation is 42 into 8. So 42 into 8?
366.
336.
36.
336. And then
430.
And 432.
432. Okay, minus 8th observation. So from here, you
248.
can find the value of 8th observation. Okay. So 8th observation. So this summation will be
48.
768 minus 720. So it will be 48. Okay. So you can solve these type of question in this way. You should know the formula. And by using the formula, you can find these values. And you can solve it in this way. You should know how to balance these type of equation. You will have to add or subtract something in that case. Okay.
Ma'am,
Hmm.
ma'am, is this lecture available in recorded form?
Yes, it will be available.
So, ma'am, can you attach the recorded link in the calendar?
You always find the YouTube links in the calendar. It's not for this particular session. Okay. You can always find the session links, the YouTube session links in the calendar only.
Okay, ma'am.
It will already be there.
Ma'am, not this particular session.
Hmm.
Yeah,
For all the
kindly
session, you
check
can
the
find.
link. Kindly check the calendar. It's already there.
Anyone has any doubt in this question?
No, miss.
No, madam.
Okay, now solve this one. So here, if the sum of 7 observations is 28 and sum of their squares is 140, then calculate the population standard deviation. Now, how will you solve it? Think about it.
First, we have to calculate variance.
Yes, we have to calculate the population variance. So we should know the formula for population variance first. Okay. So whenever these type of questions are given, you should note it down, whatever is given to you already. Okay. So what information is given to you, just note it down and then note what you have to calculate, what is asked in the question. Okay. And then you should know all the required formulas. And then by using the formulas and whatever information is given to you, by using all these things, you can calculate whatever is asked. Okay. So here in this question, we are given the sum of 7 observations. So I can write that summation of xi, summation xi, and I will be going from 1 to 7, right? We have 7 observations. So this is given to us 28. What is this line saying? Sum of their square is 140. So what is the mathematical form of it?
Summation of xi the whole square.
Okay, so it is the summation of xi whole square or
No, ma'am.
summation of
Summation
xi
of x
square?
square.
Summation of xi.
So this is sum of their square. So xi square and their sum. Okay, this is given to us. So summation of xi square. So here also I is going from 1 to 7, right? This is 140. We have to calculate the population standard deviation. So whenever we talk about standard deviation, we use variance, okay? So what is the formula for population variance? Sigma square.
Summation of xi minus x whole square by n.
Okay. And I will be 7 only. Okay, we have to calculate the population standard deviation for this data set, which has 7 observations. What should I do? How will you proceed this question now?
We need to calculate the whole square.
Yes, ma'am. Open the bracket and solve.
Yes, so we will open this square. So this is 1 upon n. Okay, n is 7. We can put this value later. So summation of I going from 1 to 7, or n also you can write. So this is xi square, then x bar is square. Okay, and it will be minus 2 xi x bar, right? Then 1 upon n summation. So we will introduce the summation in this bracket. So this will be I going from 1 to 7 xi square, right? And then here what it will be?
2 into
N into
Yeah,
x bar
suppose it is
square.
n. I'm writing it n, and then I will put the value of n. So what should be the second term?
Summation
I
of x bar square.
so
Minus
x
two
bar
X
xn.
square.
square
N
is a
X bar
Minus
constant.
xn.
N X
Minus
bar square.
square.
So it should be n times x bar square, right? Because x bar is a constant. X bar is a fixed value. Okay, it is not varying, right? So we just have to add it n times. So it will be n times x bar square, right? Then it will be 2 x bar is a constant. So summation will be at here only, xi. Okay. Is this step clear to everyone?
Yes, ma'am.
Okay. So
Yes,
x
ma'am.
bar is a constant because x bar is a fixed value. Okay. Whenever you calculate the mean, it will be fixed. It's not varying. Now, this is xi square plus n x bar square minus 2x bar. Now, if you look at the formula of mean, so x
N X
bar
bar.
is 1 upon n summation of xi, right? From here, we can put the value of xi, summation of xi, right? So it will be n times x bar, right?
Yes, ma'am.
So this is 1 upon n summation. Okay. So 1 upon, this is 1 to n xi square plus n x bar square. So this is 2 n x bar square, right? Just solve it. So this will be summation of I going from 1 to n xi square, and this will be minus n x bar square, right? Is this clear?
Yes, ma'am.
So this is
Yes,
also one
ma'am.
of the formula of sigma square only. But if you don't remember, then you will have to solve it.
Excuse me, ma'am.
Yes.
And we have been also taught this as an alternative formula to the normal formula, but the question is in which sum to use the normal formula and which sum to use this formula, means different kind of sums. Could you please give an advice?
See, this is the general formula that you can apply everywhere. So
Yes, ma'am.
according to the whatever is given to you in the question, you can use it.
No, means in certain questions, if I try to apply this, yeah, it is becoming too much large. While the normal formula what you had before written, that
See,
is
you have to see in that case, you have to decide whichever requires less calculation or which formula you can use.
yes, and that only means roughly means for which type of question the normal formula and which type of question this formula. So
No, I
If of,
cannot
if
generalize this thing.
observation
You
is
will
not
have to
given,
decide.
then you can use this formula.
See, here we are given these values. Okay.
okay.
Or if the observation is given also, then also you can use this formula.
If
It depends on you, it depends on you how you want to solve it.
if xi minus
Both
x
the
bar
formulas can be used.
xi minus x bar square is least value, then you can use the upper formula. If both the values are given, like xi square is given and x bar square is given separately, use this formula.
If you practice more and more question, you will understand it. Okay, now we
Yes.
can just put the values here. So n is 7. So it is 7. This value is given to us, right? Summation of xi square 1 to 7. This is 140. This is 140 minus n is 7 and x bar. So x bar will be 28 by 7, right? Summation is 28. So 28 by 7 will be the mean. So 28 divided by 7 and the square of it. Right? So this will be 1 by 7. This is 140. What will be this value? Calculate it.
Four.
This will be 112, right? So when
Yes,
you
ma'am.
solve, it will be 28 by 7, so which is 4. So sigma square is 4. And we need population standard deviation, right? So population standard deviation is sigma, which will be 2. Okay. Answer is 2.
Ma'am, summation of xi is given 28. But we have taken x bar as 28 there. Summation
No,
of
we
xi
have
is
divided
given.
28 by 7.
So that is divided also. Then
Yes,
it has
okay.
come to. Okay.
Yeah, so now it is mean only. Summation divided by n, so this is mean. Anyone has any doubt in this question?
No,
Any
ma'am.
part?
That formula, for our understanding, you derived it, or it is a formula we have to remember it, ma'am, from the
See, you
sigma
can
square.
remember this formula. This is also a formula. This is the derived version of the same formula. Okay, this is a general
Okay,
formula that
okay.
that you can use everywhere. Okay.
Okay,
So
okay, ma'am.
if you can remember, it's good. Otherwise,
Okay.
you can do. You will have to solve it, and then you will get the formula.
Okay, ma'am. Okay. Thank you.
Stay there for a minute on that formula. I'm just noting it down. Thank you.
Yeah, try to solve this question. Let the population standard deviation and the sample standard deviation for a data set be 3 square root 2 and 2 root 5 respectively. Then find the number of observations in the data set. Is there any relation between population variance and standard and sample variance?
The numerator is same among the both.
Yes,
There
numerator
is
is same.
relation. It is
So
n sigma square equal to n minus 1 s.
yeah, so we can find the relation between these two, right? So if you remember the formulas, the population standard population variance, okay, sigma square is 1 upon n and summation of xi minus x bar square, okay? And in sample variance, we do 1 upon n minus 1. And this part is same. So from here, I can write, if you cross multiply, so n minus 1 s square will be equal to n into sigma square, right? Right? If you take this term here, so these equation will be balanced. The right hand side will be the same, right?
Yes, ma'am.
Now we can put the values. So we are given the population standard deviation and the sample standard deviation. Population standard deviation is 3 square root 2. Population, which means sigma square. So we have to square it also. So 3 root 2 whole square. And then sample standard deviation is 2 root 5. So 2 root 5 whole square, right? Now we just have to solve this equation. So n minus 1, it will be 4 into 5, which means 20. Okay.
Equal to 80.
10.
It will be 80,
Yes, ma'am.
right? Solve it.
Yes, ma'am.
Find the value.
10.
10.
So it is n minus 1 upon n will be 18 divided by 20. So 1 minus 1 upon n.
It's
Is
9
1
is
by
the
10.
answer.
10, ma'am.
Yeah, so
1 by
1
10.
minus 9 by 10 is 1 by n. So this will be 1 by 10 equal to 1 upon n. So n will be equal to 10.
Yes, ma'am.
Okay. So this was the last question. Anyone has any doubt
Ma'am,
in
can you
any part?
explain the first step?
Yes. So the population variance, the formula of population variance is this 1 upon n summation of xi minus x bar whole square, right? And then sample variance, we have to divide by n minus 1. This is the only difference. So from this equation, you can write this equation, you can write that n sigma square is equal to summation of xi minus x bar whole square, right? And from here, we can write that n minus 1 s square is equal to summation of xi minus x bar whole square, okay? Now you can see that right hand side of both is same. So we can write that these two values are equal to each other.
Okay, yes, got it.
Okay. Yeah, anyone has any doubt?
No, ma'am.
Then we can end the session. And this PDF will be uploaded, so don't worry about it.
Ma'am,
Ma'am,
question number 1.
Ma'am, can you solve a question on biserial coefficient correlation?
I don't have question right now. Okay, but I will explain the procedure of it.
Yeah.
So there will be questions in activity. You can solve it. So what you have to do?
Is biserial coefficient important related to the qualifier?
I cannot say the important or not important, but you should know the concept. It might come in the exam or it might not come in the exam. Both possibilities are there.
Ma'am, as previous, I had gone through previous PYQs. There is not a single question related to this.
Yeah, it's still like in
Actually,
some of the paper you can find it, but yeah.
there's a question in the mock test on biserial coefficient correlation.
Yeah, better go.
Here we just take the difference or the mod value is necessary in this
Yeah,
formula.
it is the difference only. We are taking the absolute value. Okay, so this value, if you take the absolute value, it will be positive. Standard deviation also is always positive, right? And this is the proportion. So this can also not be negative. So the entire value will be positive only. Okay.
Yes.
And if you not take the absolute value, then it might be in negative. Okay. So the point biserial correlation coefficient we calculate between two variables in which one is categorical and one is numerical, right? One is categorical and one should be numerical. So what we have to do, there will be one numerical variable and one one numerical and one categorical variables. And in that categorical variable, there will be two categories. So for both the categories, you will have some numerical values. what you have to do, you have to find the mean. Okay, suppose this categorical variable is suppose male and female, right? So you have two categories, male and female. You will have some numerical values for it, whatever the data set is given to you. So suppose if you are taking y naught bar as the mean of category male, so you will have to take all those values where which belongs to this category male. You have to take the mean of those values. Similarly, you have to take the mean for which those values which are under the female category. Okay, so this is how you have to calculate the y1 bar and y0 bar. And this is the population standard deviation for the numerical variable. You have to take all the values for both the categories. Okay, you have to take the standard deviation. And then we have P0 and P1. So P0 is the proportion for this category. Okay, suppose if it is male, so it will be the proportion of the male in the entire, and P0, so then P1, so it will be N1 divided by N. Okay, so if P1 is for female, so it will be the proportion of female in the entire data set. Okay, so N is the total number of observation, and this N0 is the number of observation which belongs to male category or one particular category, and then N1 will be for the second category. So this is how you can calculate the proportion. And then you just put the values and you will get the point biserial correlation coefficient.
Okay, ma'am. Ma'am, in the y0, in the categorical, when you have to find the mean of it, you're supposed to add 1 plus 0 plus 1 and then divide by the total and get the mean, right?
Sorry, 1 plus 0 what?
In the categorical one, like y naught bar, if it's categorical, and we have denoted m for 0 and f for 1, then in order to calculate the mean of it,
No, you are taking it wrong. So the thing is, suppose the y variable is for categorical. It's a categorical variable, and x is numerical variable. So it is the data set, like suppose male, male, female, then female, suppose male, the values will be given to you like this. Okay, just a random thing. And then there will be some numerical values for this data set. Something like that. Then if you have to calculate, suppose I am y0 is for male and y1 is for female. Then you have to calculate the mean. So male. So you have to take these values. Okay. This male, this one, this one, this one, this one. Okay. So 1, 2, 2, 9, and 4. You have to take the mean of these values. Okay, not 0 and 1.
Oh, okay.
Okay, and similarly for if you have to calculate y1 bar, which belongs for female, so it will be 3, 1, 5, and 2. You have to take the average of these two. When you have to calculate the standard deviation, so you can see in the formula, it is the standard deviation of x. Okay, so you have to take all the these data, okay, all the values, and you have to calculate the standard deviation of this data set.
Okay, ma'am.
Okay, similarly, if you have to calculate the P0 and P1, P0 and P1, so you should know the value of N0 and N. So N, you have to take all the values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So N is 9 here. Okay, N0, which means the number of observation for male. So male here, 1, 2, 3, 4, 5. Okay, and N1 will be 4, 1, 2, 3, and 4. Okay, this is how we have to calculate.
Yes, ma'am. Thank you.
Excuse me,
ma'am.
Ma'am, how to calculate variance of this data? I mean, standard. If we have to calculate a standard deviation, then we have to calculate first the variance.
Yes, you have to calculate the population standard deviation. So you will have to calculate the population variance first.
Yes, ma'am.
And then you just take the square root of it. It will be population standard deviation. Anything else?
Nothing, ma'am.
No, ma'am.
Okay, then we can end the session.
Ma'am,
Yes,
there
ma'am.
is a message
Ma'am.
regarding 13 July's quiz.
Sorry. On
Excuse me, ma'am.
13 July, you have your exam.
Yes, miss.
Yes, ma'am.
Yeah, so what's the problem?
Excuse me, ma'am.
What's the doubt? Yes.
Ma'am, in the previous question which you had shown there, and we have, if we have to calculate the standard deviation, we have to take the whole data, means male and female all together.
Yes. Yes, yes.
But if among the numerical and categorical variable, can we calculate the standard deviation? For categorical variable, we cannot, I think.
So you have to
We
take the
have to
numerical variable
just
values, all the values of
just-
numerical variable x, not the categorical variable.
Sorry, means the standard deviation in this question, what you are studying, could you explain? Means how categorical variable we cannot calculate.
Not
how
for
how
calcul.
would you,
1 minute.
how would you calculate the standard deviation of the calculator?
Okay, this is
Categorical
your
variable.
data set. This x only. Do not take y. Only x. Okay.
That would be
It is the
covariance.
numerical variable.
Yes, x is a numerical variable, not a categorical. This x is a numerical variable. This y is a categorical variable. Suppose it is
Consider
the
x
marks.
as
Suppose it is marks or whatever it is,
age marks.
or age or marks or whatever it is. You have to calculate it. Okay. You don't have to take this y at that time. Okay, and whenever you are given a data set, you can find the variance. That you should know.
Yes. Yes, ma'am.
Anything else?
No, ma'am.
Okay, then thank you everyone for joining.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you.
Good night.
Hello, ma'am. Hello.